Hey, welcome back to Math with Patrick and Quill. Today is July 14th, and we're solving problem number 195 from this Daily Epsilon calendar. And we need to figure out how many factors there are for the number 320. And we've done problems like this before. Most recently, I think it was June 11th, we were asked for proper divisors. A divisor of a number is just one that divides it into a whole number. So like, for example, for 320, dividing it by 2 will give us a whole number. That's going to be 160. And so 2 is considered a divisor. In that problem, it was counting proper divisors. So 320 itself, although it does divide it evenly into a whole number, 320 is not considered a proper divisor. However, it is considered a factor. A factor is just a number that multiplies to get another, and more broadly, it's just a thing being multiplied. So if I do like 5 times 2 equals 10, these things are both factors. Also, if I just do like x times y, both of these are also factors. So when we're trying to find factors of 320, we could also just think about it as like finding divisors too, because ultimately those are kind of synonymous. Here, 2 and 160 are some factors already. So let's just kind of go down the list and see what we can make. Clearly, 1 times 320 is 320, so both are factors. We already went over 2 times 160. And let's just keep going. 3 times something I don't think is going to work. 3 divides 300 evenly, but then it doesn't divide 20 evenly. So the next number we're going to get is 4 times something. If I double the 4, I should have the 160, so we're going to get 80. And we could just kind of keep going here. 5 times something is 320. To quickly do like divide by 5 in my head, because like if I do 320 divide by 5, I will get the other factor. Instead of dividing by 5, I'll divide by 10 and then multiply by 2, because 10 over 2 is 5. And if you just kind of parse those steps one by one, you can divide by 5 a bit more quickly in your head. So dividing by 10 gives us 32. Doubling it gives us 64. That is another factor pair there. 6 is not going to work because 3 didn't. 7 probably won't work, but I'm not completely convinced. I know that 7 times 7 is 49, so if I count by my 49s, maybe I'll get around 320. Let's see what happens. Also, what I'm doing is adding 50 and then subtracting 1. So I could add another 50 and then subtract 1. I could add another 50, subtract a 1. Maybe, why not? Let's just add a 100 and subtract 2 to make this process a little bit more quick. And then, let's see, what does this number make? I would need to count up by a plus 6 and then a plus 20 to reach 320. But then I know that 26 is not divisible by 7, so 7 doesn't work. Okay, let's keep going. So 7 didn't work. 8 surely will, because 64 did, and 64 is 8 times 8. So I'm imagining moving one of the 8s over here and moving the 5 in there. It should be 8 times 40. Also, I know that 8 times 4 is 32, so that makes sense to me. Okay, 9 won't work because 3 didn't. 10 should work. 10 times 32. And then let's just double check what we got going on here. Supposedly the answer is 14, and currently we have 12 factors, so there's only one more to get. And how should we find it? I'm noticing here that 320 is just 5 times a whole bunch of 2's, right? Because 2 times 2 is 4, 8, 16, 32, 64. So we have 6 2's all being multiplied, and then finally that 5. So I'm wondering if I've already gotten all my powers of 2. There's 2, 4, 8, 32. Okay, we skipped over 16. There we go. So I should get 16 times something equals 320. 16 uses up 4 2's, right? 2, 4, 8, 16. And then, so that leaves me with 16 times 20. So that's one way to do it. You just kind of count them all up until you find them all. I think the best way to do it probably, though, is to find the prime factorization, which would look like this. And then you could ask yourself, like, using these prime numbers, what other numbers can I construct? And we basically have the option to choose the 5 or not choose the 5. And so we have two options there. And from all the 2's, we could pick any amount of 2's between 0 and 6. So that leaves us with 7 options there, right? Because like if I just start grabbing some 2's and then maybe the 5, this creates the 20 that we just saw. If I put another 2 in there, then that's 40. If I put another 2 in there, that's 80. And so all the numbers that I have in the list on the left are accounted by this strategy of picking either 1 5 or no 5's, and then any amount of 2's between 0 through 6. So with 2 options and 7 options, we can multiply those two numbers together and get 14 options, which is precisely the amount of factors that we just found already. If we choose all of them, then we get the number 320. If we choose none of them, we get the number 1. So all of the options of choosing numbers here are right here in this list. So 2 ways to solve this problem. This one on the right would have been faster, but I do like to, solve problems more concretely if I can. So there are my 2 ways. I'll stop talking. I'm all done. I'll see you tomorrow. Bye.